Our first problem says a 5-pound bag of apples costs $4.50, and an 8-pound bag of the same type of apples costs $7.52. Greg found the unit price, which is the constant of proportionality between cost and weight for each bag of apples. What is the difference in the unit prices? So when we are finding a unit price, that is the amount for one. So in this example, we will be finding the cost per pound of apples. So it says a 5-pound bag of apples costs $4.50. So we're going to take $4.50 and we are going to divide that by 5. I'm going to bring my decimal point straight up. 5 can't go into 4, but 5 can go into 45 9 times. I would subtract 45 and I have nothing left. Now I need to make sure I bring the 0 up. So that means the 5-pound bag of apples costs 90 cents per pound. Now I want to do the same thing for the 8-pound bag of apples. So it says an 8-pound bag of apples costs $7.52. So I'm dividing $7.52 by 8. Bring my decimal point straight up. 8 can't go into 7, but 8 can go into 75 9 times, and 9 times 8 is 72. So I would have 3 left over. Don't want a remainder, so I'm going to bring down the 2. 8 goes into 32 4 times, so that tells us the 8-pound bag of apples, it costs 94 cents per pound. Now we want to know what the difference in the unit prices is. So now I need to subtract these two. So I'm going to take 94 cents, and I am subtracting 90 cents, and that leaves us with a difference of 4 cents per pound. So A, 4 cents per pound. All right, our next question says, Susan's weekly earnings were proportional to the number of hours she worked. This table shows the number of hours Susan worked and the amount she earned. How much money did Susan earn per hour? So I'm just going to take one of her earning amounts and I'm going to divide it by the number of hours she worked. So she gets $47.50, and I'm going to divide that by 5. Bring your decimal point straight up. 5 can't go into 4, but 5 can go into 47 9 times. That would give us 45, and I'm left over with 2. 5 goes into 25 5 times, and I'm left with nothing. So we get $9.50. Now, because it says here that it is proportional, that means that if I take any one of these numbers and divide it, you should get $9.50. So for example, if I chose 9 hours and $85.50, so if I divide those, I should still get $9.50. So 9 can't go into 8, but 9 goes into 85 9 times. 9 times 9 is 81, so I would have 4 left over. I bring down the 5, 9 goes into 45 5 times, and I have nothing left over. So I would still get $9.50. Our next problem says this table shows the relationship between x and y. And I need to go ahead and figure out the constant of proportionality. So just like I did in the last example, I'm going to take the number in the second column and I'm going to divide it by the number in the first column. So let's take 163.5. We are going to divide that by 3. I'm going to bring my decimal point straight up so I don't forget where it goes in my answer. All right, 3 cannot go into 1, but 3 can go into 16 5 times, and 5 times 3 is going to give us 15, so we are left with 1. I'm going to bring down the 3. 3 goes into 13 4 times, and 4 times 3 gives us 12, so I'm left with 1. Now I'm going to bring down the 5 so I don't have a remainder, and 3 goes into 15 5 times, so we get 54.5. So that means that our answer here would be D. The constant of proportionality is 54.5. All right, our next problem says Mr. Kelly pays $12,564 a year for rent. His rent is a constant amount each month. That means it's not going to change. Which equation represents the amount he pays per month if M equals months and C equals the amount of rent paid for the year? So we know that there are 12 months in a year. So if I take 12,564 and I divide it by 12, that is where this 1,047 comes from in every answer. So now we need to look at our answer choices. So A says I take $1,047 per month, and that will give me the total cost. So if I know that there's 12 months in a year, this is saying 1,047 times 12, if I replace M with 12, equals the total cost of 12,564. And in this case, that would work. That would be correct. So A would be our answer choices. But let's look and see why B, C, and D don't work. So B says $1,047 times the cost for the year. So 1,047 times the cost, 12,564, would give us the number of months he paid rent for. And that doesn't make sense because if I multiply that, I'm going to get a really big number, and that's not going to give us the months in a year. All right, C says 1,047 plus M, which it would be 12 because there's 12 months in a year, would give us the cost. Well, 1,047 plus 12 would give us $1,059, which is not equal to our 12,564. And then D says the number of months, so 12 months divided by 1,047 equals 12,564, which also does not work. So you're taking $1,047, you multiply it by the number of months, and you should get your total cost, which would be equation A. Our next question says, Janet can make 4/5 of a necklace in 20 minutes. At this rate, how many necklaces to the nearest tenth of a necklace can she make in 1 hour? So we know that she can make 4/5 of a necklace in 20 minutes. We want to know how many she can make in an hour. So we want to make sure that our units stay the same. So if we're going from 20 minutes to 1 hour, we need to know that there are 60 minutes in 1 hour. So I'm converting that 1 hour to minutes. Now I need to look and say, to get from 20 minutes to 60 minutes, I need to multiply by 3. So I'm going to do the same thing on this side. So I'm going to do 4/5 times 3. That would be 3 over 1 as a whole number. And that's going to give me 12 over 5. Now we can keep our answer as 12 over 5. It also says that we can put it as a decimal. So if I make this into a decimal and I were to divide 5 into 12, 5 goes into 12 2 times. That gives me 10. I have 2 left, and I would need to add a decimal point and a 0. And 5 goes into 24 times. So you could have 12 over 5 or 2.4 for your answer. So she can make 2.4 necklaces in 1 hour. Number 17, a car used 1/64 of a gallon of gas to drive 1/4 of a mile. At this rate, how many miles can the car travel using 1 gallon of gas? So similar problem here. So 1/64 of a gallon, I'm going to make this gallons, and the car can go 1/4 of a mile. So we want to know how many miles the car can go on 1 gallon of gas. So 1 gallon of gas, and I want to know how many miles. Right, so there's 2 ways that you can do this. So I can set it up as the fraction like we're kind of used to seeing and set it equal, and I would cross multiply and divide. So I can make this into x, and I'm going to cross multiply. So I'm going to say 1 times 1/4, and that would give me 1/4, and 1/64 times x would give me 1/64 x. And then I would divide by 1/64, So I have 1 over 4 divided by 1 over 64. I'm going to keep change flip. That's going to give me 64 over 4, which would give me 16. So our answer here would be 16, or we could have this problem set up the same way and say to get from 1/64 to 1 whole, I would have to multiply by 64. So then you would do the same thing here and multiply by 64. So then we would do 1 over 4 times 64 over 1. That would still give us 64 over 4, which simplifies to 16. So we can cross multiply, or we can figure out how to get from one to the other. All right, next, a recipe calls for 1/4 cup of oil for every 2/3 cup of water. So we have a 1/4 cup of oil for every 2/3 cup of water. How much oil in cups is needed per cup of water? So we want to know for 1 cup of water, how much oil is needed. All right, so again, I can cross multiply, or I can figure out 2/3 times what is going to give me 1 whole. So 1/4 times 1 is going to give me 1/4, and 2/3 times x is going to give me 2/3 x. So then I'm going to divide 1/4 by 2/3, and I'm going to keep change flip, so that becomes 1/4 times 3 over 2, and that would give me 3/8 for x's value. To get from 2/3 to 1, if you do it that way, you'd have to multiply by the opposite, the reciprocal. So the reciprocal would be 3 over 2. So I would multiply this side by 3 over 2. And again, that would leave us with an answer of 3/8. All right, number 21 says, the table shows how much each type of meat cost at a local deli. A customer purchased a 1/4 pound of ham, 1.5 pounds of turkey, 1 pound of roast beef, and 3/4 a pound of bologna. Approximately what will the customer pay for the purchase before sales tax? So we're going to take each one of our fractions there for how much they purchased, and we're going to multiply it by the cost per pound. So a 1/4 pound of ham, so I'm going to take $5.99, and I'm going to multiply that by 1/4. And you can use a calculator on this. So $5.99 times 1/4 is going to give me $1.50. You could also multiply by 0.25 if you wanted to change it to a decimal, or you can simply divide by 4 if you know that multiplying by 1/4 is the same as dividing by 4. All right, and then 1.5 pounds of turkey. So turkey is $4.99 a pound, and they get 1.5 pounds. So we're going to take $4.99. We're going to multiply that by 1.5 or 1.5, and that is going to give us $7.49. Right, 1 pound of roast beef. So we don't even need to do anything for that one because it already tells us the cost per pound. And that is $6.99 per pound. And then lastly, bologna is $3.99 per pound. And they get 3/4 of a pound. So we're going to do $3.99 times 3/4. Again, you can multiply it by 0.75 if that's easier. And that is going to give us $2.99. Right, then I want the total amount. So I'm going to add all that up. And when I add that up, I'm going to get $18.97. And it says approximately, so we're picking our closest answer. So the closest answer to $18.97 would be $19. Right, 25 says Tony bought a $48 sweatshirt and used a coupon for a 10% discount. Keith bought an identical sweatshirt at a different store for $42.95. Which statement is true? So first we need to figure out how much Tony paid. So Tony picked out a $48 sweatshirt and he had a 10% discount. So we're going to take our 10%, we're going to multiply that by 48. So 10%, we need to change that to a decimal. So that's 10 out of 100, which is 0.10 or 0.1. So I'm going to do 48 times 0.10, and that is going to give me $4.80. That is the discount amount. So now we need to subtract $4.80 from the original price, $48. And that would tell us that Tony paid for the sweatshirt $43.20. So Tony paid $43.20 and Keith paid $42.95. And it's asking who paid less and how much less. So Keith got it for cheaper. He paid $42.95, whereas Tony paid $43.20. We want to know how much they saved. So then we're going to do $43.20 minus $42.95. That is a difference of 25 cents. So that tells us that Keith paid 25 cents less than Tony paid. So C for that one. All right, number 27 says Erica saw a skateboard on sale for $59.95. The original price was $79.95. What is the approximate discount? So first, let's figure out how much Erica saved. So the original price was $79.95, and she paid $59.95. So to figure out how much she saved, we're going to subtract those two numbers. And that tells us that she saved $20. So I know that when I'm finding a percentage of a number, I would be taking that original price and I'm going to multiply it by the percent. So the original price here was $79.95. So I'm going to take $79.95 and I'm going to multiply it by each one of these percents. So $79.95 times 0.20, because 20% is a decimal, is 0.20. And that's going to give us $15.99. And I'm looking for approximately $20. Right, so now I'm going to do the same thing here, $79.95 times 0.25, and that's going to give us $19.99. And if I did 75% and 80%, the number's going to get higher because the percentages are getting higher. But just to show you, so $79.95 times 0.75, that would give us $59.96, and $79.95 times 0.8 would give us $63.96. So we're looking for the one where she saved $20, so that would be B. That is the percent of discount. All right, 36. So the graph shows the time and distance for two objects. So we need to find the unit rate. So to find the unit rate, you are going to find a point where x and y cross evenly. So if I'm looking at my first line, I see a few points here. I see this one, this one, this one. So any of these points where x and y cross evenly. I'm going to use this one since the numbers are easily there. So then I'm going to set y over x. So remember, this is your y-axis, this is your x. So 30 over 20, and that would simplify to 3 over 2. And then I'm going to do the same thing for object 2. And I see that point, this point, several points here. So again, you're just going to pick one of them and set y over x. So I'm going to pick this one. If I set y over x, that's 20 over 30, which simplifies to 2/3. And we're looking for which one travels more feet per minute. So 3 over 2 is bigger than 2 over 3. And if I subtract these, so 3 over 2 minus 2 over 3, I need a common denominator, which would be 6. So I'm going to multiply this by 3, and I'm going to multiply this by 2. And that's going to give us 9 over 6 minus 4 over 6. And that gives us a difference of 5/6. So object 1 is traveling faster because 3 over 2 is bigger than 2 over 3. Or 9 over 6 is bigger than 4 over 6. So object 1 is traveling faster, and it is traveling 5/6 foot faster per minute. So that would be D. Right, and lastly, number 40 says the equation y equals 6.75x models the cost in dollars to purchase X pounds of steak at grocery store number 1, and then the table shows the cost to buy different weights of steak at grocery store number 2. So the equation for store number 1, the y equals 6.75x, that tells us that it costs $6.75 per pound. Now we're going to figure out from the table how much it costs for grocery store number 2. So it tells us here that it's $15 for 2 pounds. So if I take 15 and I divide that by 2, that's going to give us $7.50 per pound. And it's asking which store is cheaper and how much cheaper. So store number 1 is cheaper. It's $6.75 per pound. And then I'm going to figure out how much cheaper. So I'm going to subtract these two amounts. And that's going to give us 75 cents. So grocery store number 1 is 75 cents less per pound than grocery store number 2, which would be A.